In this video, we're going to cover section 1.3.1, measuring reaction rates. Let's consider the following reaction. We have a reactant A being transformed into product B with a rate constant K. Now, the rate of this reaction with respect to A can be expressed using this expression. So the rate of the overall reaction with respect to A is equal to minus, which reflects the consumption of A during the course of this reaction, and the change in the concentration of A with a change in time, dA dt. Now the rate of reaction is the slope of the tangent for the concentration curve at a specific time. This is often referred to as the instantaneous rate of reaction. Therefore, the reaction rate will depend on the time at which the rate is determined. To see this a little bit more clearly, we again return to this particular figure where we have a curve representing the decay of the reactant and another curve representing the growth of the product. We're plotting the concentration of each of those species against time. And what's highlighted by this dot is a particular point in time during the course of this reaction. And if we draw a tangent to that particular point in time, whether on the reactant or product, the slope of that line will represent the instantaneous rate of the reaction at that time. So as you would expect, at early times in this reaction, the rate of consumption of the reactant will be larger than at longer times or later times during the course of the reaction. Similarly, early on, the rate of product formation will be quite high, and then it will slow as the reactant concentration decreases. So the instantaneous rate of a reaction can tell you a lot about the rate at a particular point in time for that reaction. And again, recall that because the reactant is decaying, the slope of the tangent will be a negative value. But if we go back to our expression, that negative value inserted here, multiplied by the negative sign in our expression, will give an overall rate, which is a positive quantity. Now, how does one define a reaction rate if the rate changes with time? Well, one convention that is used is that we define the rate before the reactant concentrations have undergone any substantial change from their initial values. Under this condition, the reaction rate obtained is called an initial rate. Overall, however, the rate of a reaction can be determined at any time if the rate constant, order dependence, and concentrations at that time are known. For example, suppose experiments demonstrate that the previous reaction is first order in A, first order overall, and the rate constant is 50 seconds to the minus 1, such that we have this particular expression. As a result, for every concentration of A, we can calculate the rate of the reaction. So if you have any questions about measuring reaction rates, by all means, send me an email. Thank you.